Hey, this is Dr. B, and right now we're going to talk about covalent network solids. These are a really fascinating group of substances, and it's certainly one of the most obscure types of bonds, right? You've got ionic, you've got covalent, you've got metallic, but how many of you are familiar with covalent network solids? And yet, I'm sure many of you are familiar with, if not all of you, with things like diamond and quartz and graphite. Those are covalent network solids. I like to think of them as being similar to metals, but with non-metallic elements, right? Metals just have this continuous lattice that it can exist in 3 dimensions. Well, so can some of the organic substances. Carbon can do so in a tetrahedral fashion like this. Notice that there's no, what's the molecular weight of the substance? Well, it's almost like a polymer, right? It's kind of extending in all directions. It could be up to millions. And so people say it has a molecular weight of 12, but they're just dealing with one individual part of it. I find that fascinating. Graphite extends, but in just a linear fashion and with a weak intermolecular force here, which makes it act almost like a lubricant, like a solid lubricant. This one is still called a covalent network substance, but I see an individual molecule here of C60. I also see a soccer ball, in fact, identical to the soccer ball that I played with in high school. That's pretty weird. This is known as a Buckminster fullerene or a buckyball, or more commonly just C60. Here's another one. This looks like glass. Here's yet another one. So these are all covalent network solids, and there are some other more rare ones here. So let's just line them up. Which one's this? Well, which one's that? That's graphite. Which one's quartz? Got to have some silicon and 2 oxygens. C60. Graphene. In the news constantly. Supposed to have all sorts of really funky properties. People are trying to turn into something useful. I don't think they've had much real world technical success. And there's diamond right there. This is an introduction to covalent network solids.